Hello there. Hi, everyone. Good morning and good afternoon for some of you, maybe good evening. Let's start this webinar. So, just to introduce myself, I'm Uma Mukara, Head of Chaos Engineering at Harness. I also helped co-found Litmus Chaos, the chaos engineering project that's hosted on CNCF. So I run a community of chaos engineering practitioners, developers at large at CNCF through Litmus Chaos. I also work at Harness to build the enterprise version of the chaos engineering product. So at the end of this session, you'll be able to understand a little bit more about the security foundations that you need to understand if you're trying to start and scale the chaos engineering practice in your organization. Security understanding, security requirements understanding is pretty important if you really want to get a head start and scale the chaos engineering practice, right? So before we get into the security requirements, we'll do a quick recap of what chaos engineering is all about and what are the general challenges if you choose to start and go up and scale chaos engineering practice. What are the general challenges that I've observed? And then we'll specifically focus on the security part of the requirements. That's where we've been getting some general questions by the people who really want to go and start chaos engineering implementation. And then security and governance are closely related. We'll go and do that. And in the last 10 minutes or so, we'll spend some time about how Harness Chaos Engineering product demonstrates or adheres to these security requirements. With that, so let's talk a little bit about what is reliability, right? So reliability and resilience are two different things. Reliability is a collective responsibility of SREs to make sure that there's maximum uptime. And you want to avoid not just uptime, you want to avoid the latency escalations. So many times a slow system is also targeted or marked as unreliable system, right? So if the system is not reliable, that really means that there are a lot of incidents that are happening, a lot of outages that are happening, right? So if you want to increase the reliability, you need to make sure that incidents are not happening, or they are kept for a smaller, shorter duration, right? So then, what is resilience, right? So you cannot really control when the faults will happen. May not be, everything may not be in your control, right? So, but what is in your control is how you make the systems resilient, even though there are faults happening, right? So generally, if you increase the resilience as an effort, you tend to increase the overall reliability, right? So if you want to increase the reliability, focus on increasing the resilience of the system, not avoiding the faults that could happen on your system, right? So that's what chaos engineering is really about, right? So try to increase the resilience of the system by actually measuring and finding the weaknesses, and then coordinate with your teams to go and see what we can mitigate, which risks can be mitigated, or which weaknesses can be fixed. So chaos engineering is really about measuring the resilience, right? And how do you measure the resilience? You get the actual resilience scores, put a number to a resilience, and also try to cover maximum amount of scenarios, right? And what is the outcome of chaos engineering practice is really you'll be able to eventually reduce the number of outages, right? So that means you increase the MTTF, mean time to fail. But you, in the short term to medium term, you'll be able to see the reduction in the recovery because you now know the weaknesses. You can recreate the scenarios. You'll be able to reduce the MTTR. So that actually reduces the severity of the outages or incidents being declared many times, right? So this is just a summary of it. Chaos engineering is a structured way to introduce controlled fault or controlled experiments into systems and then try to measure whether the system is continuing to function as expected. Then the resilience scores will be good. If the systems are not working as expected, then you found some weaknesses against those failures. Doing it in an automated way at scale is really when chaos engineering practice will give real benefits, right? So we talked about why, right? So you can reduce MTTR, outages can be avoided, so on and so forth. So then you go and introduce this as a new culture for many organizations. Chaos engineering is a new cultural thing to get used to, right? Because you are trying to do proactive introduction of failures, which is something that many people will not take it easily, right? But it's really about accepting that there are some weaknesses and then try to improve the resilience by structurally measuring and acting upon them, right? So what's needed really to practice is an intent to do this fault injection and measure the resilience, right? So key stakeholder sponsorship is very important, and their commitment to back the practice of chaos engineering is very important. And then, of course, the tool should help you do most of the common tasks by itself, and then you need to have a good design, right? So just doing few chaos experiments usually will not help. You need to have a plan to increase the resilience test coverage, and then stand by what you find, and be able to recreate the same scenarios, show the weaknesses again and again if needed, and then provide that feedback to the teams where they can either recover faster, improve the scripts to make the systems recover faster, or actually fix the issues, which will avoid potential outages in the future, right? Where do you do this practice is, in my experience, I've seen chaos engineering practice is mostly well practiced. It's feasible to do it properly at scale in lower environments, right? So you can do some amount of game days in production, but the resilience test coverage is really in the QA or pre-prod performance test environment, so on and so forth, right? And both SREs and QA teams can practice in their own way. These are generally, two different aspects. QA teams will try to use chaos engineering as a way to test resilience and make sure that we are not introducing new resilience issues which were potentially fixed earlier. So we want to verify that they're not there. And then, QA teams generally want to increase the resilience coverage over a period of time so that, they can identify the known weaknesses or unknown weaknesses and make them as known, right? SREs generally, they do it as game days, but there's a lot of feedback that can be shared between this lower environment chaos practitioners versus production environment. That's where the maximum benefits can come out, right? Where is it being used today, right? So mostly in financial services area where the cost of outages is very, very high. And chaos engineering is also used as a method to improve the DR testing, right? So it can be very highly efficient, save a lot of cost. And then when the systems are highly scaled, you don't have much control. So you just go and do practice chaos engineering as a way to test the unknown risks, right? And finally, Kubernetes or cloud native environments attract chaos engineering practice a lot because naturally Kubernetes has a way of doing introducing faults by itself, pod deletes. So, and there are too many microservices, a lot of dependencies. So it's whenever Kubernetes deployments scale, you need to have chaos engineering almost as a mandatory step, as yet another form of testing into your load environments. Now, let's talk, if some organization wants to adopt chaos engineering, they've chosen a tool, and then there is sponsorship about how to, go about and scale it up. The adoption challenges are of 4 folds, and today we'll talk about security permissions in this session, right? So skills is really about, because it is a new cultural stuff, it's a niche technology, having people with good chaos experimentation creation skills is a challenge, right? So even if you have a few experiments, you'll still need to figure out what more experiments to be created, how to automate them, and how to interpret these results, so on and so forth. Primarily, the security permissions play a lot of hindrance role in the beginning for adoption as well as for scaling up. We'll talk about these things in a little. So let me move on to the governance control. Once you have security permissions and once you have skills, you will have chaos experiments being run. But then, you still need to have great governance control to specify who can not do what or who can do what, so on and so forth, right? You want to be able to do the control of malicious intent. Just because there are chaos experiments that are available, you don't want people to just go and start deleting or start slowing down your internal infrastructure, right? And then, governance also is about who's doing what, right? So that's really important. That's a challenge that one needs to solve, right? And then finally, if you do govern well and then you find a lot of risks, the challenges then would be how to qualify this risk, whether they're real risks or not, and then, how to address them immediately, and the overall resilience posture, the coverage, as well as the scores. How do we go and interpret and push that feedback into your SDLC plans or your release plans, your performance test plans? These are some of the real challenges, right? And then, this risk, when you find who needs to really go and look at mitigating them without actually doing this bringing blame into the picture, right? So blameless attribution of the risk is sometimes a real challenge, right? However, we're not going to focus on all those challenges. We're going to focus the next 10-15 minutes on the security aspects of these challenges, right? So these are sometimes can be seen as requirements from security perspective. So if you are aware of these requirements and plan well, you can get off to a good and fast start, and then avoid some surprises later on in your adoption cycle, right? So let's look at one by one, right? These things in detail. That's what this session is all about, right? And before we go deep into it, you might hear, if you have come across the selection of tools, right? You're validating a particular tool, right? Or you go to your security teams, right? To look for some permission approvals, so on and so forth. And then, people might hear that in this question, hey, I cannot give you these permissions. Really go and run it yourself or choose some other technology, right? Maybe this particular tool is asking for too many permissions, right? So the answer to that is, if someone is saying that I can run chaos experiments of some sort without requiring special permissions or some permissions, then there actually is a security issue, right? So you're letting someone do the deletion or slow it down without a proper permission. Either security posture is not really good or the tool is not really good, right? And if it is actually demonstrable, that really means that something else is going on by that tool, right? So if this can be explained in a slightly different way, right? If somebody is saying that we don't need much permissions like the other tool, then you're really looking at that tool creating those permissions or service accounts automatically, those RBAC policies during the installation of the chaos agents, right? So you might have given some admin permissions during the installation of chaos agent. That will go and set up in the background all the other permissions required to execute the future chaos experiments, right? So that's it's better to do specifically by asking, here is a permission that you need to give so that I can execute or orchestrate certain type of chaos experiments. So be aware of that. So now let's take a look at an example of a SaaS service that's providing, chaos engineering as a capability as a SaaS as a service. And in this case, I've taken harness chaos engineering, right? So you can generally see that there's a control plane where you can go create chaos experiments. Then when you run it, they actually run in your enterprise network, right? Private enterprise network. So, and then, some agents will get this chaos experiments from the control plane, and the chaos experiments run on different types of targets. That could be either Kubernetes clusters or, various types of cloud resources or VMware or any other virtual machines, technologies, Windows, Linux, PCF, so on and so forth, right? Whatever could be, the requirements around security can be classified into 7 different types, right? So these are kind of like requirements that you need to be aware of, right? The first requirement is the entry to your private network should involve opening up only an inside-out connection, right, to 443, because like you're installing a chaos agent, that should not be able to be contacted from outside from the control plane, right? So that it's really kept secure, right? So, and also usually 443 is the only port that you would require. If you open up more ports, then again, there could be some other tools that can be compromised based on which port it is, right? The next one is a lot of security issues will come through the software image vulnerabilities. So a lot of organizations, enterprise organizations, they manage their own image registry where they scan and they have a signing process depending on their internal policies, right? So you need to have a clear possible way to sign those images into a private image registry, check whether the tool can do or not, right? Sometimes the signing may not be allowed, right? So you can change the name of the images, but not really re-sign them, right? So this is something to be aware of in this security context. The next one is most of the times you will end up having a chaos agent running in your private network. There are some agentless models as well, right? So, or a very thin agent or on-the-fly agent. But in general, there's somebody who's responsible for receiving the chaos experiments and running that, right? So you need certain permissions, right, to put that. So make sure that you're not giving excessive permissions for this chaos agents or runners, so that they get only the required permissions, not a blanket everything permissions, right? And what happens when you give permissions? You tend to receive a chaos experiment and then run, which has some permissions to do something like delete some stuff or kill a network, so on and so forth. So that can be used. That permission can be used to do something else. Somebody can use that service account and then go and do a non-chaos experiment malicious process, right? So we need to avoid that. Make sure that the tool or framework supports just-in-time privilege escalation, right? So you don't get this privileges all the time. You get those permissions only when a chaos experiment is pushed to the chaos agent, so that you won't run the risk of privilege escalation all the time. For example, you are running chaos experiment, so 1% of the time, or 5% of the time in a month, the opportunity to do that escalation stays only into that percent, right? And the next one is really, how do you handle the secrets, right? So secrets, of course, open passwords, open credentials is never a good idea, but there are standard secret policies that most organizations will have. How do you handle your secret management capabilities and so on and so forth? So make sure that the secrets that are required to either connect to your target resources or connect to install anything. If you are providing the secret, they are followed. They're following your expected policies. They're complying to your policies rather than you complying to the tool's policies. For example, you may be using Vault, HashiCorp Vault, as a way to keep the secrets, and everything is in on-prem. Then the tool should support storing the secrets in that vault, not the other way around. Same thing applies to connect to the application performance management systems like Dynatrace, Datadog, New Relic, so on and so forth. It's a common practice to go and connect to them during the chaos experiment execution or orchestration, right? So you can do read-only access where you go and check a metric value, or read-write access where you're also putting an annotation on a dashboard of this APM. So you need credentials to dynamically access these APMs, and they are also securely stored, and if possible, they are provided just in time only during chaos experiment orchestration, right? This is a pretty important thing to remember. And many times, especially in the financial services and large enterprises, you will not have connectivity of your core systems to the internet at all, right? If you're using a SaaS service, it's still possible to securely, run chaos experiments and work through the SaaS control plane. How you do that is by putting a forward proxy in the required place, and the tool should be able to help this proxy configuration dynamically to all the chaos experimentation execution logic. Otherwise, you'll end up having running chaos experimentation capability only to certain parts of your enterprise, not to your core systems that may be, strictly deployed deep into your enterprise and can be accessible or can be connected only through proxy. So make sure that this proxy configuration capability is there. And in the end, I would say how much ever you plan and execute, there's always a chance that something gets out of control, right? So maybe somebody deleted, instead of 50% of the pods they deleted 100%, right, by mistake, right, and then unwanted or unexpected things start to happen, right? So that's what we call the blast radius getting out of control, right? So the tool or the chaos experiment should be capable of detecting that, hey, the latencies are all too much, and this is not what we wanted to expect. We are finding a weakness, but let's actually stop the rest of the chaos experiment or the current ongoing one, right? So that's an important security requirement for a chaos engineering framework or a tool, right? So next, let's talk about, we talked about security requirements, and then we can talk about now governance, right? So many times people make it almost the same, our bags are for security, right? So, but yes, they are somehow related. If you do a great governance, good governance, it leads to better security, right? So you are controlling, making sure that things are not happening, either good intention or malicious intention, making sure that the chaos experimentation is very much controlled and adhering to the governance policies of the organization, right? So what are the general good examples of governance requirements, right? So you can think of separating it out into two lists, allow list and block list. Allow list is about who can run chaos experiments at which time. Block list is who cannot or what experiments are blocked on which agents. Experiments are consisting of certain faults are blocked, and experiments targeting certain applications are blocked, right? So if you mix this combination, the allow list and block list together, so the governance can be thought about as you can govern all scenarios where who's blocked from running what type of chaos experiments through which chaos agents on which target applications during which time window, right? So this is what a great governance tool should be able to help you configure, right? You can put a lot of rules and allow list and block list, right? So in Harness, we call this allow list as rules and block list is called as conditions. So rules and conditions can help you define a detailed governance policies, and then you can be rest assured that chaos orchestration is well under control. Nothing goes outside what you wanted, right? So with that, let me just go and spend some time on how the security and governance requirements are complied in Harness Chaos Engineering. So this is a Harness Chaos Engineering tool from Harness, right? Harness is a platform, provides multiple capabilities, right? All related to how you can improve the efficiencies of people and product services in the SDLC cycle, right? So chaos engineering is part of that. You can run it alone or in combination of with others. Product features where it can gel well. Some seamless integration is available, for example, with CD, right, continuous deployment. But general, the Harness is available both as SaaS as well as on-prem service, right? So you have chaos experiments that you have constructed, and chaos experiments are each chaos experiment can have various types of nodes, in which the fault nodes or probes, which are like checking your hypothesis, right, and actions, right? So notifications or introducing delays or calling webhooks or starting a load test script, so on and so forth, right? So this, using Chaos Studio, you can create a well-defined scenario and make it really possible for enterprise. This is like very much capable of converting your expectation into reality in an automated way. So when executed, this is how it looks, right? So you can see an executed chaos experiment, what falls have been executed. You can go and look at detailed logs, so on and so forth. And then similarly, which probes failed, so on and so forth. I'm not going to spend a lot of time on what the product is, but spend really some time on where this 7 items are configured in the tool, right? So first is like 443, that's fine. And we can now go and look at the second requirement where the image registries are all done, right? So if you look at the chaos image registry, here we allow whatever are the images that are required. You can pull them, refer them to your custom images. All you need to make sure is that these images are put in your private image registry. So Harness offers full-fledged support for maintaining custom images that are required for running chaos experiments. And then let's go and look at some security aspects around the secrets, right? So secrets, if you go and look at, there's a detailed Harness secrets manager functionality by the Harness platform. So Harness Secrets Manager can store secrets itself, or it can support external secret manager, etc., etc. Here, in this case, we are storing something on Splunk OBS, for example. And it also provides capabilities for storing connectors secrets as well, right? So let's say that if you go and look at this connector, the details required to connect to Splunk are actually stored in Splunk OBS again, right? So these values are always stored in a particular way. Harness offers full-fledged support for secrets management, not just for chaos engineering module. All modules, some security point of view, will not expect you to put secrets or open passwords anywhere in the product configuration. So the next one that I want to cover is the proxy settings, right? So this is one of the common things that I've come across in the large enterprises, right? So some parts of the applications are always stored in an environment where network connectivity by default is not there to the external environment. And if you are using SaaS, how do we go and secretly or securely put this connectivity, right? So I'm going to an environment, and this is the environment. Let's say that a gapped environment that's there, and I can go and then set up some proxy configurations for each environment, so that whatever the proxy that's installed and connecting that particular target infrastructure to the SaaS, those details can be filled in there. So advanced configuration, advanced configurations such as this will help in connecting the control and execution planes and make sure that they are orchestrated in a very secure manner. So the next thing that I want to show is how you connect this APMs in a secure manner. For that, we have something called probes, right? So probes is a way you do the checks by connecting to various different types of target systems. And for example, we have the ability to connect to the following target APMs, right? So it requires certain permissions that are dynamically collected at the time of chaos experiment execution. And these are all done through connectors, right? Harness platform offers something like connectors. Again, they are pretty much part of the platform. You can see that all these connectors require again, credentials through the Harness Secrets Manager. So that part also is covered pretty well from security point of view. And the other one, if I had to go and look at the last one that we talked about is how do you stop, or how do you auto stop the blast radius problem, right? So for that, we have the capability of configuring stop on failure, right? So let's say that I go to this chaos experiment that we have here, and we can go to a probe, right? And then go to the probe properties and then stop on failure, right? If you make it yes, whenever this probe fails, the entire experiment gets stopped, so that if you are doing some pod related failures, all the reversals will be taken care. And for example, if it stops here, the rest of the chaos experiment will not even go through. And then you don't need to really worry about manually observing. In this case, like let's say a latency is going beyond on a certain value for a particular service, that really is not good. So let me stop this chaos experiment totally. So that's like stop on failure capability that we provide as part of the experiment or a probe capability itself. So that's what, and then Chaos Guard is another governance capability. It's, as the name suggests, you can really guard against some malicious intent for chaos experimentation. So I have something called rules and conditions, and rules is really, who can do this chaos experimentation, right? And then it controls the time, right? So every experiment execution goes through matching of each rule. And whenever a rule is matched, that really means that the time is matching and the person or the user is matching, then it will go and look what conditions I need to enforce, right? And the conditions really, the conditions are really about each condition can specify what is blocked, right? And where is it blocked, and which application is blocked, and which service account is blocked. So this is basically one block list, right? And then rules are allow list and conditions are block list, right? So a combination of that would help prevent unwanted orchestration of chaos experiment. So that's the demo that I wanted to show, right? And then there's a lot of documentation available with the product where you can actually detail information is available about required permissions. I'll quickly go through it, right? We do offer the capability to run certain type of experiments, even if you don't have root permissions, right? And even for Kubernetes, if you don't want to provide depot permissions, you can still do with whatever is available, right? It is basically configurable. That's what we don't enforce a stronger permission requirements. If you don't have it, you don't need to do it, right? And AWS is, it's got multiple resources. You can go and configure various roles and policies around it. It's very detailed. The documentation is available. And then similarly for Linux, there is a detailed list available about what are the experiments that are available for, let's say, VMware Linux with root, right? Of course, with root, almost you can do everything. And non-root, there are certain chaos experiments that you can do, right? So detailed documentation again is available. So basically, to summarize, we're not forcing all experiment permissions on each account, right? So depending on what you get as a permission, you can plan your chaos experimentation orchestration accordingly. So just to summarize, the security permissions are really highly context specific, and a good tool will provide all the requirements that I talked about so that you are in control of configuring this policies related to security permissions, and then it also allows you a good way to do the governance around chaos orchestration. That's all I wanted to cover in this session. We can do some Q&A now. Let me see if there are some questions. All right. Let me pull this up. Right. There are some questions. Is governance and security control are same in the context of chaos engineering? They are related. They're not same. So basically, a better governance leads to better security, right? So you want to avoid somebody running a malicious, it's like an IP filter firewall, right? So if you don't have firewall, there's a security issue. So similarly, if you don't have governance policies, definitely running chaos experiment is not safe, right? So that's that's what it is. And second one, let's say, who owns the blast radius control in chaos engineering practice? Usually, whoever runs chaos experiment that owns the blast radius control. But as mentioned, if the tool, if the tool is thinking about blast radius control in a powerful way, the creator of the chaos experiment can also control the blast radius at runtime by putting something like a stop on failure, right? So in good design, you would leave this responsibility to the experiment creator, not the experiment runner, right? Because runners are usually, they run the chaos experiments in our automated way. But somebody else who created these policies or experiments should cover that through either governance policies or blast radius getting out of control. You can check through probes and then stop if it's getting out of control. All right, so the next one, how practical it is. Let me just display how practical it is to do chaos experimentation on Linux if you don't have root privileges. Certain chaos experiments, you can definitely install the agent and then it's running as non-root. And as we showed, there are certain experiment that you can do as non-root. For example, here, right? So our Harness tool offers running some JVS chaos experiments and even CPU, memory, disk level stress, and process scale. All these experiments can be done as non-root. But API chaos, network chaos, those are somehow related to the kernel in Linux, and then they require privileged permissions such as root. The next question, how is Harness chaos engineering product different in the context of security? Is it more secure? How? Great question again. So Harness chaos engineering as a product is designed to provide as many policies as possible, to set your security controls, right? How do you manage your stop on failure requirement? How do you manage your admission controllers so that you are running the chaos agents only when necessary, just in time, privilege escalation, making sure that Harness delegates are not requiring outside in permission. It's also only inside out permission. And then, every experiment can be controlled through Chaos Guard. So it's really about going into the detailed requirements and providing almost a choice of a configuration for this administrator to control the security in a way they want, right? So there's no blanket statements that we make in the product that this is how the security works. We make it possible to configure it, right? So that's the beauty of it. I think we have one more last question. Who controls Chaos Guard in Harness? Can it be compromised? It cannot be because Chaos Guard itself is is governed through its own RBAC. So there is like a role for Chaos Guard itself, right? So Chaos Guard rule, whoever you want to assign this particular role with the Chaos Guard rule create permissions, only they can go and see this Chaos Guard and configure new rules. It's like a firewall admin, right? Firewall admin access is governed through RBAC configurations, the same way it is done for Chaos Guard as well. So it cannot be compromised. All right, I think that's all the questions we have. I think we're up on time. Thank you for joining this session. And you must have seen some CTAs, so you can go to harness.io and sign up for a free trial. And also the free plan includes chaos experiments that you can run for free forever, a certain number of chaos experiments. And also you can get a good demo of it, so on and so forth. With that, let me stop sharing and thank you all for joining this session.